All right, so we've got an air standard diesel cycle. It's phrased a little bit differently from what we're sort of used to. We're given a displacement volume, which is the volume at top dead center, or the volume at bottom dead center minus the volume at top dead center. So I've got all my givens, all my finds, all my assumes, and I'm ready to go through and solve my cycle. So let's see, let's check out the first one. So the work net output is equal to big W net out, and that's equal to the mass times little w net out. So let's look at the little w net out first. So we could put that as the work output between 3 and 4 plus the boundary work between 2 and 3 minus the work required for the compression process between 2 and 1. But we might want to simplify it just a little bit and put it in terms of Q net in as opposed to work net out, because for any cycle, work net out and Q net in are equal to one another. So that takes care of that part of the equation, but I do need to take care of my mass as well. And because I've got air standard assumptions, I'm using air as my working fluid, it behaves as like an ideal gas, I can go ahead and apply the ideal gas law, and I can calculate the mass based on that. So there's the work net output equation that I'm going to use, and now I'm going to get the power net output. And it wants it in kilowatts, so later we're going to have to just make sure that we pay attention to our units. So the power net output, it's going to be in it's kilowatts, so it's going to be in kilojoules per second. So part A is calculated in kilojoules, and part B will be kilojoules per second. We're going to do kilojoules per minute and then convert it to kilojoules per second. So it's work net out times the number of cycles per minute, because per each cycle it creates, or it generates, the same work net output as what's calculated in part A. And then for part C, let's see, I need the thermal efficiency. I've calculated that several times, so I kind of remember what that equation is. But once again, if you need a review, go back to the diesel cycle video. All right, so those are my governing equations. Now I just need to go through and figure out all the stuff that I need to plug in there. So at state 1, let's see, I know the temperature, it's 295 Kelvin or 22 degrees Celsius. So I can pull off the U value on my ideal air tables. And now let's go to state 2. I know between state 1 and state 2 of an isentropic compression process, so I can apply an isentropic relationship for an ideal gas. And VR1, I can go ahead and pull off of the table at 295 Kelvin. And then V2 over V1, well, this is just, if I multiply the top and the bottom by the mass, I get things in terms of the volume. And so I can calculate, because I'm given the displacement volume, which is V1 minus V2, that's 3 liters, and I'm given V1, which was 3.17 liters, I can plug in the numbers and get V2 over V1. And I get a VR2 value of 34.740, and if I interpolate, I can get the parameter that I need, the property that I need, which is H2. All right, now I'm ready to go on to state 3. So I need H3, that's what I'm after. I cannot apply an isentropic relationship between 3 and 2, but I can apply my ideal gas law. So a lot of things cancel out. R cancels out on either side. The pressure at P2 and P3, those are equal to one another. Those cancel out. And so what I'm left with is T2 times V3 over V2, and V3 over V2 is just my cutoff ratio, which is 2.5. So I actually don't know what T2 is, but that's okay. I can pretty easily figure that out. If I go back over there to state 2, I know VR2, so I can just interpolate on my ideal air tables for the temperature corresponding to VR2. And if I plug that in, I get a value for T3. Now I'm ready to go into my ideal air tables again and interpolate for the H3 value, which is 2554.6 kilojoules per kilogram. Now let's go on to state 4. So let's see, what do I need at state 4? I need U4. All right, well, between 3 and 4, I can apply an isentropic relationship because I have an isentropic expansion process. I'm going to go ahead and pull off that VR3 value at T3. Once again, I'm going to have to interpolate. And I'm going to notice that V4 and V1 are equal to one another. And I'm going to do that manipulation that we often do with diesel cycles. I'm going to put that V1 over V3 in terms of the compression ratio and the 1 over the cutoff ratio. So V1 over V2 is R, V2 over V3 is 1 over RC. So I know RC, that's no problem. And V1 over V2, oh, I actually do know that. So I use that back at state 2 to figure out state 2 when I apply my isentropic relationship. And so VR4 is 14.110, and I can interpolate for the U value in my ideal air tables at VR4. And now I'm ready to plug everything in. I do need to watch my units for part B, make sure that I convert the minutes to seconds to get things in terms of kilowatts. But other than that, everything is pretty much plug and chug. All right, well, I hope that was helpful. Well, I take that back. It's not plug and chug. You've got a liters up there in part A. So make sure you convert the liters up to meters cubed. And there's a direct conversion factor in your conversion factor sheet. Okay, now thank you for watching. And I hope that was helpful. Let me know if you have any questions.